So wastewater heat recovery
Mhm.
has been around for how long?
Since early 2000s, really.
All right. Fairly significant time then.
A fairly significant time, yes.
So why has no one heard of it?
A lot of it is just down to regulations. So the Part L 2021, when that came into force last June,
Yeah.
that's when people started to look at it. So obviously, before there was a slight slump in kind of building, and before people just started pouring concrete foundations in, people were looking at it, and we almost had a bit of a false start because there were so many houses that weren't on Part L. But now it's just ramped up massively.
Lots of people won't have heard of wastewater heat recovery, or even in their mind when they've heard about it, they'll think, is this kind of grey water harvesting?
Yeah.
Can you just explain what it is?
Yeah, so wastewater recovery generally is when we shower, we use water at 40 degrees. So we've mixed cold and hot water, and it comes out at 40 degrees from the shower head usually. And that then goes down to the drain, and that's about 35 degrees. It's a lot of energy we're wasting. So wastewater heat recovery, we harvest that energy that's still in the water. We harvest that heat. And so the water runs down through the waste pipe, our copper tube, and then the cold mains runs counter the opposite way to it. And so it's counterflow heat exchange. So the wastewater is separated from the mains water by 2 walls of copper. And all we're doing is we're extracting any energy left in that water, and we're sending that back to the shower. So when you use wastewater heat recovery, you can use half as much hot water.
Okay.
So it's a significant amount of water you can save, energy you can save.
So it literally is 50% less
Yes.
on the heating for your shower.
Yes. Well, actually, it's more than just 50%. So in essence, there's 3 ways to install it. And the most efficient way, and what you'll see most residential buildings, is class as System A. And that is where 100% of the water you use to shower is brought through the wastewater heat recovery unit. So when you shower, the wastewater runs through, and the cold mains comes up, extracts that heat, and goes from around 10 degrees to around about 28 to 30 degrees, and then goes to the cold inlet of the shower and to the cold inlet of the hot water source, be that a gas boiler, unvented hot water cylinder, heat pump cylinder, or an instantaneous electric heater. By doing that, you've reduced your hot water draw by half, and then you've also reduced the energy required to heat your hot water, because you're now heating water at 30 degrees to 60 rather than 10 degrees to 60.
And so how much in pounds and pence then do you think that wastewater heat recovery is going to save the average family of 4 people, say as an example, each year?
So take it, I think, from a modern home like today, if there was an A-rated gas combi in there, which most people have got, if they were showering for kind of anywhere between 6 to 10 minutes each person each day, the average household would save anywhere between £200 to £300
a year.
Yeah. Now, depending on the settings of the boiler, depends on how far away the boiler is from the unit. There's obviously different factors as well, but on average, they would save around £200 a year. And that's kind of a baseline. So within a year and a half, 2 years, it's paid for itself. And from then onwards, they're constantly saving energy.
So a couple of questions here around that then. So if I've got a house and I've just bought it from a developer and they've installed Showersave, or they've installed some kind of wastewater heat recovery, am I going to need to get someone to come and fix or maintain it on an annual basis, or?
No, so our Showersave units don't need any servicing. So the normal gravity-fed unit, which most developments will have, which will be the unit, the 2.1 meter tall copper tube, will be on the floor below your shower. 99% of homeowners will not have a clue it's in there. So whether it be housing association tenants or new build buyers, they'll not have a clue it's in there.
So no one's going to advertise a house and stick it on the front saying, this has got wastewater heat recovery.
It's what we find is that developers go, it's just something else for people to worry about, or something else for people to go, well, what's this? What do I need to do with it?
Right.
So the homeowner pack will say it's on there, and we do get some calls from new home buyers who are quite studious at looking through the homeowner's pack.
Okay.
And it's great. We can explain to them what it does and why it's amazing and how that's going to constantly save them money. The big thing with these new developments is that there's no maintenance for the normal gravity-fed units. There is no planned maintenance. So the installer needs to install it properly as per our installation instructions and Water Regs UK guidance, and then pressure test it. Once they've pressure tested it, the unit's boxed in, plastered, painted, skirting boards on, carpets in, sofas in, nobody knows it's there.
So you can't see it?
You don't see it, no.
Oh, wow. Okay.
We've had a couple of installations where people are really intrigued with the technology, and we've got one gentleman who's a passive house consultant up in Scotland, and he's actually installed it so it's live and you can see it. And so whenever he has people around, they have, come and look at my shower pipe working, look at the energy it's saving. And people just don't believe it until they touch it. And so we explain to them what it does and how it works. And then when they feel the actual working of it, so they can feel the bottom of the pipe and they can feel it's 10 degrees at the bottom, and they can move their hand up to the pipe. Often we have a little step ladder for them to stand on, and they feel the top, and it's around 28, 30 degrees. And then we'll have little temperature readouts to show them. And then as soon as people do that, it's in their brain that it definitely works and it's worth having.
What are some of the barriers then of specifying this from a developer or from an architect's point of view? What are some of the things that they don't understand that prevent them from specifying this?
I think the majority of national house builders all understand what wastewater heat recovery is now. And so it's specified on, thousands of plots each year. I think our message or our goal or challenge right now is to make sure that all those regions of those specific developers understand fully how it should be installed, make sure that the contractors know what they're doing, because there'll be a lot of contractors who have never touched this before. And so from June last year, they've had a crash course.
Okay.
So it comes down to us then to make sure we educate them, we support them, we give them the facilities and the tools so that they know what they're doing, so that they can install something which is going to work for years and years to come, which is going to constantly save money.
If I'm a plumber and I need to install this stuff, am I going to get paid extra for installing it? Because I'm just thinking, it's going to take me more time. Is it complicated? Is it a faff?
No.
I just want to get on site and get the stuff done I need to do and go home.
Yeah, so most new build sites, what you'll find is that you've got breeze block walls or timber frame walls. You've got floor ceiling joists above you, which you can see underneath it, you can get to. What we find is that if you install the unit once or twice before, about 20 to 30 minutes will have you installing the unit. And that's from kind of markings onto the wall, fully connecting up to the waste pipe and connecting up the mains water as well. For new or refurbishments, whether it be to social housing properties or to retrofit for normal homeowners, changing the bathrooms and things, it will take a little bit longer, but it's not going to take an awful long time. It's not going to take hours and hours worth of work. It's really just making sure that they've got in their mind and they've read the instructions.
Right.
As all installers, as a previous installer myself, instructions go behind one shoulder and you get on with the other.
Well, I do that anytime I put up furniture in my house. The instructions are gone and I try and figure it out. So is it quite intuitive, the way that it all goes together, or do you literally need to read those instructions? It's quite challenging.
So we've got a new version of our product. So it's the same height. It's 2.1 meters tall. And it's called the Showersave QB121XE. And we've specifically changed that so it is kind of installer proof, foolproof.
Okay.
So there's only one way you can install it. There's no way you can reverse it, and it really is as simple as that.
Okay. So super user friendly.
Super user friendly. We've shrunk the instruction manual down to really short, sharp, brief messages, QR codes, so installers can go straight to the videos to see. And it really is a simple way to install an energy saving device.
So talk about this now on the more technical side of things. So if someone needs to do a SAP calculation, you did mention about passive house, and I know that passive house, you don't need to do a SAP calculation in order to pass a passive house, but you do for building regulations. Yeah. What difference does wastewater heat recovery make within the SAP calculation?
It can make some massive difference there, Darren. One of the big things is that if we take a normal house with a gas boiler that just isn't passing, what we find is that as soon as someone sticks wastewater heat recovery on, you can add kind of anywhere between 10 to 15% on, which then just brings it to a pass. We find that some developers are using it almost as an insurance, because you've obviously got design SAP and then you've got final SAP.
As built, yeah.
And so when you do that as built, whether it be not as airtight as it should be, you've got a leaky building, having wastewater recovery there is an added insurance, really. It guarantees you get through the regs, but not only that, it helps save money in the long term for the end users of the property.
It's a cheaper option than PV, I guess.
Yeah, an awful lot cheaper. But again, with these things, it's not a one size fits all. You cannot just install Showersave and then that's going to get your house through regulations.
Okay.
We need to work together with these different manufacturers. We need to create properties which are energy efficient, thermally able to keep the heat in. So you need to have high therm lintels. You need to have key light roof windows with the thermal collar, which keeps that energy and that heat in. And then you want to save the money through your domestic hot water. All these kind of technologies together, when they're kind of put through the SAP calculations, can make a huge difference to the health of the home and the health of the occupants, but also the running costs of the home as well. So if we have a wastewater heat recovery unit alongside a heat pump, for instance, we all know the biggest challenge for a heat pump is producing hot water. It's fantastic at producing heating for a home. Just keep it on constantly at a low temperature. The radiators stay warm. The occupants are cozy. as long as they don't fiddle with the dials.
Hmm.
But the struggle then is producing that hot water demand. So by using wastewater heat recovery, you feed that water back into the cylinder and you reduce the demand of energy. So you make the COP of a heat pump higher because it's not fighting to produce hot water. You could also shrink the cylinder size potentially because you don't have to produce as much hot water anymore because you've halved the draw when you're showering. So it can make a massive impact if designed correctly and installed correctly, along with all these sort of technologies.
Which is super useful because next to the demand for the space heating, the energy that we need to heat hot water is really quite significant.
Yeah, so we've made homes extremely thermally efficient now. So every new build will be really good at keeping the heat in. That envelope is really good at keeping the heat there.
Yeah.
That energy demand has really dropped. Now the biggest demand of energy now is actually hot water. And we find that between 50 to 60%, depending on occupants and things like that, 50 to 60% of the energy demand is actually through domestic hot water now.
So this is now replacing where space heating was. It's now actually going into the energy that's going into to heat the hot water.
Exactly that, yeah. So your primary energy demand is being reduced because you've got your wastewater recovery unit in there.
So talk to me now then about where you see this fitting into the Future Homes Standard.
Yeah.
And things that you know about the home energy model.
Yeah. So for the Future Home Standard, we obviously know that the goal is to produce, net zero by 2050.
Yeah.
And we're trying to constantly reduce that energy by decarbonisation, by electrifying the grid. And so by using wastewater heat recovery alongside these other technologies, so instantaneous hot water heaters, heat pumps we've already discussed, you're reducing their electrical demand. One of the big challenges that developers have is the electrical connection sizes. There is a cap to how many heat pumps they can install on certain sites because the grid size isn't there yet. So by making it possible to reduce that electrical demand by using wastewater recovery, makes a huge difference. For me, it's about reducing, one, the energy, but also making sure that the homes are cost effective to run. Because once we've passed the keys to the tenant or the homeowner, they've got to live in it for 20, 30 years, however long they're there for. And if these bills are astronomical because we've put a load of electrical technologies in to heat and to provide the needs for the home, we haven't thought about their needs. We need to make sure that the whole lifespan of the house is efficient in terms of using of energy and being resourceful for the amount of energy it uses. Because there's no point throwing wasted water away, as we've already discussed. Once that water's heated, let's try and keep that heat for as long as possible.
So how does that heat actually get transferred then to the hot water? Because I'm thinking here, I've got a pipe, and when I see my water go down the pipe, it doesn't go down in an orderly way. It's just So, but how do you actually extract the maximum heat from the water as it goes down the pipe?
Yeah, so our product is 3 layers of copper, basically. So you've got 3 copper tubes. The very inner one is where your wastewater runs down. And what we want to do is we want to hold it within that pipe for as long as possible. The longer that water is in there, the greater time we've got to recover the energy.
Okay.
So that's why we have this cyclone at the top, and that sends the water around the pipe. So that clings to the wall all the way down the inner tube. Then we have...
So you're having a spiraling effect of the water?
In essence, yes.
Okay. Does that mean then it drains slower?
It's still as fast as it normally drains. It just takes us longer to get to the top. So if you imagine, a coin in the machine.
That's what I'm thinking. Yeah, it takes ages to go down.
It does.
If I just drop it, it just goes straight down.
But it's constantly going fast, isn't it?
Okay.
So it's not going really slowly. It's still going faster. In essence, it's traveling further.
I understand.
But at the same speed.
Yep.
So it's traveling further at the same speed. And while it's traveling that kind of further distance, or it's being delayed to the bottom, we're sending that cold mains water up through there around the outside. And that wastewater is then separated by 2 walls of copper to keep protected. And then that extracts the heat. So it's basically a very simple heat exchanger.
Okay.
But it's tested to make sure it's efficient as possible.
Okay. What are the properties when it comes to life cycle, green credentials? You mentioned copper quite a few times there. So this is not something that is made from recyclable materials?
So the main pipe is 98% or 99.5% copper, which is 100% recyclable or reusable. What we say is if you buy a property in 20 years' time, Darren, and it's got wastewater recovery, and you're demolishing it, or you're doing some renovations to it, send it back to us. We'll test it. we'll make sure it's as efficient as possible. We'll give it a clean and we'll give it a stamp of approval and send it back to you. And you can reinstall it and it can be running for another 20, 30 years.
Oh, wow.
So it's copper. At the top and bottom, it's two brass unions where the cold mains comes in and out. And then the rest is just where you feed to and from it is normal waste pipes. So in terms of green conventionals, we're doing everything possible to reduce the amount of energy we use to produce the material, to produce the product, and we're doing everything possible to reduce the energy taken to get it from A to B. So from our factory in Holland, we've reduced the number of deliveries by not packaging it in Holland. So we ship it as in the manufactured pipe because we can ship twice as many per pallet as we could when we're boxed. So then they come to our distribution hub in Burton, we package in Burton, then we send out throughout England. So we've shrunk the amount of trips we had to do. We've reduced the number of trips we've had to do, should I say. And then we've also got Becker packaging. We've reduced the amount of plastic in it, so it's all recyclable.
And how far does this product go? Is it just UK based?
So we distribute it throughout the whole of the UK and Northern Ireland and Ireland, and it's sold throughout Europe as well.
Okay.
So we manufacture in Holland. That's where our factory is, and we manufacture it. So it means we can influence the research and development, but then we distribute it throughout Europe as well.
That's fantastic. What are some of the ways that I could maybe use this type of technology if I have a bungalow or if I live in a ground floor flat? I'm thinking you've said you need a 2-meter drop.
Yeah.
And I don't remember showering in the attic of my bungalow.
so I live in a bungalow right by the sea. So mine's an old 1960s bungalow. And so I'm going to put one of these units in. So what we've done is we've got the normal pipe and then we've put a gravity-defying pump. So we've got a sensor which took an awful lot of research and development. And this sensor detects the wastewater. And that's just below the level of your shower tray or your bath trap. And that then tells the pump that we've got wastewater there to lift the water to the top of the unit and then run through the pipe as normal. So we've defied gravity by having this sensor and pump. But the big thing we've got there is the pump is a diaphragm pump. So it's a piston which moves in and out, and there's a diaphragm which causes a suction and pushing motion. So that doesn't clog, doesn't get any hair stuck to it. It means it's really, really robust. And then our sensor as well has no kind of flow switches or anything. We've specifically designed the sensor so that should anyone turn the power off, I don't know if you're the same as my house, but my kids love turning the lights off and the power off when I'm in the bathroom. So if anyone decides to turn the power off and the pump's turned off, the water will still get to waste because we've got a built-in overflow. So you've never got a shower which is out of commission.
I'm with you. Yeah. To be honest, in my house, it's usually the other way around. It's
is it?
Playing the practical jokes on my kids as opposed to the other way around. Okay, so that's interesting then. So what about for non-domestic facilities? So I'm thinking here of sports centres, leisure facilities, hospitals, care homes, hotels.
So anywhere where you've got wastewater being used at the same time as you're drawing kind of the mains hot water, you've got an option to use wastewater heat recovery. So commercially wise, you look at hotels, leisure centres, anywhere where you've got a lot of wastewater or hot water being drawn and put out to waste at the same time, you've got an option to use wastewater heat recovery. Any kind of new build hotel, you look at, the Hampton by Hiltons or things like that, where they are often built off site, there's a great opportunity to install them. You can install them on the floor below the shower in the pods. They can be done in the factory off site and then just craned in. And you can reduce the hot water draw by half. So you think before they might have to have had 3 or 4 clarifiers at 2,000 litres each. They may get away with 2 or 3 clarifiers now, but they're reducing that peak demand of energy. We've actually got a project up in a couple of projects in Scotland, the first Passive House Leisure Centre and the first Passive House High School. And they've used the Showersave Blue QB121, which is the pumped unit. So it's the normal gravity fed unit with the pump. And they've got one of those units between 2 showers. And every time that shower's running, and when you think of a leisure centre, it's going to be used all day. And people are only showering for 10, 20 seconds at a time, but they're constantly being turned on and off. And so they're reducing the hot water demand by half every single time someone's showering. Laundrettes is another option where you've got commercial laundry services. You're talking about hospitals where you've got medical washing and you've got to have water at a certain temperature. So there's plenty of opportunities. We're doing some work at the minute in central London with some student accommodation providers, and they've obviously got to reduce their energy demands. So they've obviously done the usual things. So they've reduced all the lighting to low voltage lighting, and now they need some other wins. And when we look at using wastewater heat recovery, and we run through the calculations with them. They're making massive gains and they can make a huge saving. Now, if they can put that into the design stage, then it makes it a lot easier because it's done at the start. They don't have to think about trying to move things around and trying to get access to things. They can design it at the start and make it work from get-go.
You're passionate about this, I see.
Yes, for me, it's about reducing, doing everything we can, everything physical possible to reduce the energy used. We've only got a finite amount of resources. We've got a plethora of opportunities to use a lot of good products to reduce energy and to reduce bills. 10 years ago, you asked at the start, 10 years ago, energy bills weren't drastic. People could run the house on a gas boiler really quite cheaply. But when that energy crisis kicked in, people started to make positive changes. People started to monitor the showering. Smart meters became more prevalent, so people use those, and people are aware of their demands and their usage now more often. And we look at electric cars and people using those, and people trying to use the cheapest tariff at night to charge for it, so it's cheaper, just to reduce those bills each month. And anything we can do to help a home be healthier, to help a home be more affordable for people to live in, better.